We're live. So welcome everybody to a new episode of Platform Engineering. So today we got Jon. Hey Jon, how are you doing?
Hello, good.
Joining us from Trondheim, Norway. And we'll talk about the levels, how to pick the right level of abstraction for your platform, which I think is a very interesting topic and something that we've had a lot of conversations about during PlatformCon that a lot of different speakers chimed in on. And I think in general, it's a very interesting topic in the community, in the platform engineering community. So looking forward to the session. As usual, this is being recorded. It's also being streamed live on YouTube. So we'll send the link tomorrow in a follow-up email alongside any useful resources, links, and stuff that Jon will show. So don't go crazy on note taking or anything. Feel free to use the chat to say hi. Feel free to use the Q&A. If you have questions, it's better to use the Q&A so that we can sort of stack them and upvote them as well. And if you do use the chat, please send to everyone and not just to host and panelists, because otherwise only Jon and I see that. Yeah, I think that's the housekeeping. Jon, over to you. I'll shut up.
All right. So thank you for that introduction. My name is Jon Skarpeteig, and today I will give you guys a little intro to obvious, consistent, and predictable platform abstractions. So Luca already mentioned a little bit of what I do, but over my career, I've always been passionate about empowering developers, and that's through self-service APIs, tools, services, knowledge, and support. And that is now known as typically an internal development platform. I've done so through enterprise, startup, and now my latest adventure is that of a scale-up at a company called Signicat, where I am the tribe lead of the global platform tribe. So I'm based at the Signicat headquarters in Trondheim, in Norway. So how do you get platform abstractions right? So the first thing I wanted to bring up is Gall's law. It says that complex systems that work evolved from simpler systems that worked. So if you want to build a complex system that works, you want to build a simple one first, and then you want to improve it over time. And make no mistake, an internal development platform, that is absolutely a complex system. There's no use pretending otherwise. So how do you go about that? Typically, when you have platform engineering, that is because you have an organization that can support it. So you typically are over a certain size, where you start getting multiple teams that have multiple services, often labeled microservices. And often these microservices are put in containers, and now you're stuck with a bunch of microservices, and microservices has needs. So inspired by the Maslow's hierarchy of needs, to get started, you really have to start with the basics, the things that you absolutely do need. Otherwise, you won't get anywhere. So you need hardware, you need storage, you need networking. Which essentially means you will need to pick a hosting provider, and you need to pick a hosting provider. The days of hosting this in your basement are over. Unless you have extremely specific requirements, please pick a hosting provider to help you run this. And then you need somewhere to have your code. So it can be built, stored, you can have tests, whatnot. And then you need to connect this with your running system, so that you can actually get the code up and running somewhere so it's useful for somebody else. And with the basics in place, that's when you want to start going up the chain, so to speak, to look at more interesting or more value-added services on top of your when you're serving the basic needs. So what could this look like? I'm going to tell a little tale of the Signicat platform and how we went about it and what we, well, essentially learned from that one. So once upon a time, Signicat was the one tech stack. The startup was okay, it kind of worked, not the best, not the worst. And then we grew, and then the strategy changed, and we started acquiring companies. So the first acquisition came, and then a whole new technology stack appears. Then we did another one, and they actually have two technology stacks. They had an old generation and a new generation. So, okay, containers to rescue, part of the story. But we needed to consolidate. We needed to figure out how can we create one platform that is useful for all of these different groups and parts of the business. So we went with the basics. We started, okay, we need to choose a hosting provider. And we, at that time, had 5. So out of 5, preferably we want 1. Then we also had a numerous set of tools on top of that. We had to try and agree on that. And then we also had to figure out what is a valuable platform for these different teams, because if it's not perceived as valuable, it won't get used and you will stick with whatever you had from before. And this might differ in different organizations, and we had to figure out what this meant for us. And then once we figured out all of that, we set this up, we lived happily ever after. I'm hoping we will get there one day, but that's a bit of a fairy tale to think that you're done. So when we did start out with the basics, the first thing we wanted to tackle is the hosting provider. But when you're standardizing on a hosting provider, that can have quite a wide impact. So if you have ever migrated hosting providers, you will know how excruciatingly painful that might be, which means that you get an inherent, very strong bias towards what you have from before, because that's typically less work for you. So what we found is that change management through consensus, that is extremely powerful for a strategic decision, which has this kind of wide impact. Because it gives you anchoring in the organization. Once you have a decision, you can quickly enter execution mode, so you can start building it, start implementing it. And when you get new hires, new people on board, when you do additional acquisitions, you have an organization that is able to educate the newcomers about the trade-offs and the reasons why the choice was made. So what worked well for us on this particular problem was to start out with requirements. So verifiably objective criteria. We used the RFC style document of must, should, and may. And that was quite helpful in battling this confirmation bias, because if you have pre-existing preference, then all evidence that points to this one being the right one will prevail. But if you have this objective list, then it's one tool in the toolbox to try and counter it. And of course, technology is absolutely not the only criterion. It's cost, it is their support model, it's compliance, it's skills in your organization. I mean, you have to be able to operate it. And the ecosystem around it is also quite important. So what we did, we ran a completely transparent, open process. All of the meeting notes were public. We documented all disagreements, all arguments, all counter arguments. And we were very clear on the trade-offs. And at the end of this, we actually ended up with the working group taking it to a vote, because there were 2 finalists. And
Jon?
after that, it was presented to the decision
Jon?
maker. Sorry?
Maybe, so Kashmir has a question. Who is at the table? So who's we when you say we for getting this consensus? I think it's a good time to answer that maybe.
So we in this, it is the platform tribe, and in the context of Signicat, that's the we.
Okay.
Right. So once you have reached, this is what we want to do, you need to anchor it. You need to get the final decision, and, which is the final decision, present the recommendation, get the decision makers involved, stamp of approval, you're done. And then there's really no turning back, so that you really can accelerate them and build upon what you have agreed upon. So now you have your basics. You have Kubernetes, which is the typical container platform chosen. You have your code and your artifact, you have your hosting, you have your pipelines to get your code onto Kubernetes. Now what? So in order to get a production grade container platform, you also need some non-technical and other value added services on top. So you need to set up the boundaries between the teams and the responsibilities, in particular between the platform teams and the service teams or the product teams. You need to do some security hardening so that you can ensure that it's compliant. You need monitoring and alerting, logs and metrics, collection. And this is where the landscape starts becoming a little more complicated, because there's a lot more choices, there's a lot more permutations when you're combining all of these tools. So what we then came up with in Signicat is this set of principles. Now these principles, they are tailor-made for Signicat. And the business context here is that Signicat is a hyper-growth company. We were doing consolidation across multiple technology stacks. And we are providing services in the digital trust space. So that means stringent security and compliance requirements. Financial and GDPR is two important ones. So what we came up with is that we wanted to have ease of use for service owners, and service owners in this context are the ones that are solving the customer problems, making products that we ship. And if that meant more work for the platform owners, so be it. We also wanted to emphasize that we wanted industry standard solutions. Even if there might be somebody that's arguably technically better, we still wanted to go with the dominant player if in doubt. And then we needed to be secure and compliant by default, but we have a very strong preference towards low complexity when possible, so that ease of use is real still. So the Signicat container platform here is this is essentially what we came up with. This is the high-level overview of the most crucial components of the container platform. Using a vendor for hosting, load balancer, and managed Kubernetes. We have automation around certificates because we had a requirement to host some of these ourselves. We have an Istio API gateway, which is also the service mesh. And then we set up an observability stack where Grafana is the one looking glass into it, so that you can go to our Grafana instance, and then you will see all things observability through that one interface. So the security and ease of use, that is sometimes a little bit at odds with each other. But we had a very strong goal to have service owner developing and launching new products without asking anybody in platform for permission. But that also means that we have to provide guarantees that one team should not be able to ruin somebody else's team's deployment. So we need separation. And we also need separation between platform and service owners. And the boundary is the API gateway. So the API gateway, configuration, setup, maintenance, that is on the platform. But the configuration of the API gateway, that is on the service owners. And if anybody has worked with Istio, you might know that the virtual service it's possible then to steal somebody else's path if you have another virtual service definition on with the same matcher. But what we did there is to implement an open policy agents gatekeeper to add isolation and to ensure that you can't overwrite an existing path. So this is one example where we went the extra mile on the platform side to figure out the solution to make it easy to use and make it approachable for the service owners. So this is the responsibility matrix. It was extremely useful to make it very clear who was responsible for what, because this is a source of confusion continuously. So one example is we chose that backup and restore is within the responsibility of the service owners to back up their data, because they are really the experts on what data is useful and how you can have procedures to restore it if there's any state that you need to think about or any other bootstrapping. There is no operations that will do this for you. Platform tribe will not make backups for everyone. This is farmed out at Signicat, and then of course there are things that is platform, especially around the Kubernetes cluster level. So making sure that the tooling and that we can provide an SLA on the platform itself, on the container hosting, is then within the platform tribe's responsibility. So on top of the container platform, there is the 3 pillars of observability. And when building the Signicat platform, we needed a few iterations to get this one right. So we had the design goals, ease of use, industry standard, secure and compliant. And we wanted to standardize the observability stack because we had several competing ones from acquisitions and Signicat. So we needed common tooling, we needed common protocols, we wanted efficient operations because we were starting to see quite some volumes of logs and our telemetry, essentially. So we had a situation for metrics, the Grafana Prometheus, it was the de facto standard. Everyone was using it, easy peasy, we just go with that one. For logging, we actually had 3 competing implementations, and the Kibana Elasticsearch stack was the dominant one. But we had some challenges there because we started to see some of the operational challenges when you get this 100+ terabytes data in there, which is a bit cumbersome to operate. For tracing, we didn't really have a good solution. So when moving to microservices, we're actually lacking visibility into how all of the microservices interconnected. So the first iteration, the first one, we started with the basics. Again, we just get some tooling installed, so it's there, so it's possible to use it. We chose the Grafana with Loki. It was already in use in the company, and it's really good for cost optimization. So you have this pattern of write once, read never, which is quite common for the bulk of logs. And it had Grafana integration, which enabled us to have this one looking glass, this one abstraction that's all things observability. You go to Grafana and then you have access to the full buffet. For tracing, we didn't really have much experience with that. We just took the most known brand to us at the time, and we introduced that one, and then we integrated that also into Grafana. It also had Kiali integration, which was quite nice because it's a nice tool in front of Istio. And then metrics was kind of a given. Now, just providing people with the tools didn't really help. People didn't want the drill, they wanted a hole in the wall. So for logging, everyone knows Grafana, right? Yeah, no. Loki has LogQL, which is very similar to PromQL, but coming from Kibana, rather managed log services, they're used to nice UI interface with a little text box, typing in their query and then getting the result. And with Loki, they don't have an index, they have labels. Then people were expecting an index that they can use it as on any other search. For tracing, we introduced a tool, but since we didn't really have any pre-existing experience, it wasn't even used. It just sat there idle. So we didn't really get the benefit of collecting or having a tracing suite in place. And part of the journey of the containerization also means that there is a lot more metrics because there's a lot thing on a common platform. And we also had teams coming from a more virtual machine-based setup where it's not, well, the paradigms of CPU and memory usage on a node, it's not as relevant in Kubernetes because it's distributed and it's across multiple nodes and there's autoscalers kicking in when they need to. So the first dashboards that the teams were added when they got access to the metrics in the first iteration was CPU and memory usage on nodes, but it didn't really say anything about the health of the application platform as such. And also this scraping of metrics endpoints, it was perceived as a bit magical because the way we had set it up was to trigger on annotations in your deployment, and that's kind of not so accessible unless you know about it. So it just didn't happen, and then it was, but it doesn't work. Well, why? And it took some iterations to get this right. So what we did for logging, and this was at least to me the biggest surprise on how efficient it was. We simply created a Grafana dashboard that had a free text input field and then drop downs for some common filters like Kubernetes namespace. And we put it on the homepage of Grafana. So the first thing you will see when you log in is a link to here you get the logs. And all of the grumbling or comments and bad reviews from people that were used to Kibana and other more managed services disappeared overnight. So fairly simple thing to do, tremendously useful because it lowers the bar to get started and to get value out of the tooling. Same thing with tracing. You create examples, you create a dashboard showcasing the few brave souls that actually have traces sent in there. And with the abstraction through Grafana, the backend, the data store, the data source for Grafana, that's kind of hidden. So we replaced Jaeger with Tempo, and we could do that without any user impact. We just did it, and that was that. So that worked quite well. And for metrics, we also needed to find something that was universally useful. And then we introduced this RED metrics, requests, error rate, duration. And then we're covering then all the services. So just by doing that, you get the value of the services covered in the default dashboards that we have. We also did reference implementation, so you can see how you can implement this metrics endpoint, so you can get in-service statistics and metrics scraped directly through to Prometheus in this new world of containerization. We also had an iteration around alerting, and this one we struggled with, I think, the most, and we still haven't really cracked this one yet. So we had Alert Manager. We figured, okay, it's in use already. Is there a difference if we create a custom resource definition to define the alerts? Yes. The cognitive overhead of configuring alerts to a different system ended up with not being used at all. So, okay, what do we do? Let's do a reliability day. We're going to do workshop and do trainings, you know, and the whole shebang. Turns out a workshop doesn't necessarily translate to operational responsibilities. So connecting the dots on why it was useful for the individual teams when we were in piloting mode wasn't really obvious. So we got some usage, but not really too much, although it was well received and people did enjoy getting more information and trainings on this new type of technology. So, okay, but we have to launch in production. We can't have a meaningful software as a service uptime without some alerts in place. So there came the mandates. We created a checklist. You have to check all of these boxes in order for you to launch into production. Otherwise, it won't be accepted. And on that checklist, it says you have to have alerting. What happened was that people went to the workshop. They took the example of check if Prometheus can scrape the metrics endpoint on individual pods. Not the best alarm, but that's what happened. And then, of course, one night on call gets woken up because there is one individual pod that didn't get the metrics scraped. And then, yeah, grumpiness followed. So we found that getting good alarms is really a continuous improvement cycle, because what you really want to do is to align customer pain with engineering pain. You don't want to inflict pain on engineering unless the customer is in pain as well. You still want alarms, but you can deal with that at the daytime, not to wake up on call. And we also are doing an effort to create a good knowledge base so that if there is an alarm and you wake up in the middle of the night fairly disoriented, trying to figure out what's going on, there is a clear description, there is a clear debug path and what could possibly be wrong, and hopefully also a way that you can mitigate or even resolve the situation. So, tooling in place, time for the top of the pyramid. That is essentially looking at how to help the teams, how we can, get the organization on board. And for us in Signicat, that meant really catering for the early movers, because the concept of an internal platform as a product is really powerful, because that means that you can do product management, and then you can leverage product management techniques. And the reading and the lessons learned from product management. So it's about getting early movers to really adopt it and advocate it. Then you get the networking effects, and you get help with onboarding because other teams will follow them. So what we needed to ensure was that there was a sense of ownership over the deployment. They needed to do the backup. That doesn't mean that the platform can't help to provide guardrails. There we have the open policy agent. We also have some compliance boundaries so that you can't purposely or you can't by accident break compliancy or breaking the law, essentially, which we need to be quite careful with. And it also means that we need to market it. We need to make it known. We need to get adoption there. We need to run presentations, workshop, demos, really spread the word so that the platform is attractive, it works. This is how you get started to really get it ingrained in the organization. So out of the platform adventures, did we learn anything? Maybe. So there's one thing that I think is worth highlighting, and that is what is known as the speed, cost, and quality trade-off. Common knowledge is that you can't really have them all, you have to choose. But I think this is actually flipped on its head when you're making an internal development platform, because your cost is essentially engineering time, which is quite costly. And cost reduction then comes from speed. If you remove friction from developers and they're able to move quickly and spend less time on the platform and more time on solving customer problems, that has a value that reduces the cost. And speed, it comes from confidence. If you're confident in the platform, then you can operate quickly and you can roll out your changes also quickly. So confidence comes from quality. So if you have high quality, perhaps counterintuitively, it becomes cheaper for the organization. So for Kubernetes, the abstractions I would recommend is that the responsibility has to be clear, but you really want to empower developers. They really love figuring things out on their own. And one thing we did which was quite successful was to have transparency by default. so that developers have read access to production in other teams' namespaces, so they can look and learn on the source of truth on actual running things in production. And you also really want to target stability, because otherwise you won't get adoption, and it's just miserable for everyone. So even if it means some extra hoops to validate that your upgrade will work the way you intend to, you really want to emphasize on that. You don't want to assume abstractions from Kubernetes are well understood. So these wonderful abstractions for the load balancer and the networking, they are now exposed to developers. They have to reason about it. So they have the service definition, they have the deployment definition. And some teams aren't used to that because they've been cushioned from that by operations. And you should absolutely not underestimate the power of a graphical user interface. So when our developers started to discover Lens, that was quite successful, because then they were able to reason around the Kubernetes itself. Now, we did hit a snag with that one, because the service mesh was interfering with it. So Lens was actually DDoSing our servers. But then we took the time to figure out what was going on and fix the endpoint so that Lens weren't spamming us anymore, so that it was actually could still be used by engineers. Access management, actually a big topic, but you want to have an abstraction away from the individual. Using a group-based membership is quite useful for that, so that if you're a member of the group, then you have the access. If you're removed from the group, you lose the access. And you also want to follow the principle of least privilege to protect integrity, availability, and confidentiality, also known as security. But it's when you start thinking about it, the risk factors, you want to focus on the integrity and you want to focus on availability and confidentiality. That means that the discussions around it becomes a bit easier, because it's then specifically about this one thing. It's not this all-encompassing security, which you can use as a blanket to do whatever, actually. You don't want to forget about break the glass measures. Even if you have this wonderful abstraction, you have single sign-on, everything's perfect, it might break, and then you need some a backup plan to get in there. The last one is a bit of a practical one. If you have individual single sign-on users in Terraform, when they leave the company, your Terraform will break. Don't do it. The observability, we had quite success with implementing all the 3 pillars. You want the batteries included, and you want to align engineering pain with customer pain as your on-call approach. You don't want to assume tool proficiency. We failed there. That's lesson learned. So if the tooling isn't perceived as being valuable, then it isn't really valuable, because you won't get it, it won't be used. And making assumption about what is the minimum valuable product is also not great. You need customer feedback, and your internal development teams are your customers. You need a good feedback to understand the problem they are solving, and then what the problem that you need to solve for them. And then supporting the organization, really emphasize that teams are customers. Embrace product management methodologies. They are extremely useful to make sure that you're building the right thing, something that has impact. And avoid making platform a bottleneck. So you have to be sure that what you do can actually scale with a growing organization. And you absolutely don't want to limit creativity in your organization. So be generous with transparency, giving access when you can give access, and lock down, of course, what needs to be locked down, but don't lock down everything by default just because you can. And be sure to build something that is loved by someone. So listen to your reference customers, your early adopters, make sure that you solve it so that they are happy, because that has a tremendous impact on those that comes after. So to sum up, obvious, consistent, and platform abstractions. Be mindful of Gall's law. You really want to emphasize the principle of least astonishment. because it's about reducing cognitive overhead. That reduces the friction. And that also means reducing the number of things required to learn or relearn. So you really want to see how simple you are able to make it for the end user. If you are in doubt, go with the dominant design, which means to go with the one that has the highest likelihood of the most people already being familiar with, because that will ease adoption. And only use abstractions if they are actually removing cognitive overhead. Otherwise, don't do it. Then it's better to have it all exposed. And finally, without customer validation, meaning internal teams validation, the platform is not valuable. So, key to your customers, and good luck. Thank you. That brings us on to the questions phase.
Awesome. Thank you, Jon. That was great. I really liked the language that you used for a lot of those things. Really resonated. All right, we have a ton of questions. So I'll start from the chat. So Arthur is asking, from an implementation perspective, would you recommend Git for change management?
Let's see if I recommend Git for change management. So depends on the change. I mean, if you're changing your culture to work more with DevOps practices, that's a different change management than what you want for code. But for tracking changes on your deployment, absolutely, that is a good idea. I know there's plenty of good tools around there. Argo CD is one that is quite used for that, which is quite nice. So depends on what you want to have changed, I guess.
Yeah. Kashmir is asking, what challenges did you face when services got deployed without consulting the platform team, and how did you tackle them?
So we didn't have challenges per se, because we wanted to encourage creativity, meaning that we wanted a fairly generic platform that was extensible and quite flexible. We did have some interesting ones that somewhat had requirements of huge load, and then they started doing load testing. And then they weren't really familiar with inner workings. And then there's this finger pointing session that is a bit hard to avoid. At the end of the day, is that you have to dig deep and figure out what was going on. And if you don't really have a good understanding of how the platform is architected, then it's also a bit hard to track it down if you don't have if you don't use the tools available in the way that we were hoping that they would be used. So then it's about engaging with the team. Then it's about getting them on board and also understanding what they're trying to do, and then see how we can help them. Then it's more of a site reliability engineering thing where you actually go into the team and be more together with them to help solve the problem together with them.
Last question from the chat. How do developers create resources in the platform? Everything is abstracted as a Kubernetes resource?
No. So of course we have some Kubernetes resources. Alert Manager is there, and then we have the virtual service from Istio, and we also have the CRDs from Cert Manager with certificates for domains. But we also granted people their own tenant on our hosting provider, so they were able to spin up managed databases, managed storage, and other parts of the hosting provider's portfolio directly. So we were maintaining a container platform. That's typically the workhorse. And then if they have dependencies that is special for them, they might need some special options for the database cluster that is within the team to operate. That's at least how we do it now.
Got it. All right, so going over to the Q&A, Daniel is asking, did you have multiple cloud providers and standardized on one?
Yes, we did have multiple cloud providers. I wish I could say we standardized on one. We standardized on two, but that is essentially customer driven. Why we ended up with two. But it is we have one primary, and then we have some special requirements for the second one.
Andreas, if you gravitate towards having more work on the platform side to make it easy to use for others, how is the amount of engineering work distributed between platform teams and feature teams?
So right now, the platform teams is almost 30% of the organization. But the platform in Signicat means also internal services. So we solve things like billing, we solve things like token factory and authorization. So there's a lot of work also for services that isn't making us money directly, but has to be there as part of the platform.
Interesting. Shane, would platform enable the capability of backups which service owners use, or is the entire solution the responsibility of the service owners?
So we provide out of platform, we are typically the subject matter experts on a lot of the technologies used. So our approach is that we provide guidelines and best practices, but ultimately the responsibility of the backup is within the service owners. And we chose this because the complexity of knowing all of the products and their inner workings is just unmanageable from a central location.
Totally. How long have you been on this journey? What time scales did you see for the various kinds of changes and for learning cycles?
So I think this depends quite a lot on the organization. For us, we had a very direct business need because we had essentially, after the first two acquisitions, we had 3 solutions solving the same customer problem. So there was a very strong drive for consolidation, so that we solve the customer problem once and we sell it to all our customers. And from that, we were starting to build a platform. So that also meant that the buy-in in the organization and the resources available were appropriate to accelerate that. So for our journey, it took about 2 years to get significant traction on the new platform setup.
This is a good one. What kind of abstractions do you deliver to devs to deploy new application? Is a Helm template? I think that's interesting because a lot of times, yeah.
Yeah, we do have Helm templates. They are not universally used. We're also looking at Argo CD as a solution to that. But right now, the standardization is Helm charts. Some are written by the teams without the templates. Some are leveraging a template as boilerplate. But it varies a little bit between the maturity of the team and also their how early they were in adopting the platform.
Totally. And wouldn't it make sense to standardize that against like a few boilerplate templates, just provided centrally by you as the platform team?
So as a starting point, I think it makes sense to standardize it. But then it's more of a guide, not really a mandate as such, because mandating thing, we are very hesitant on that because we want to have an attractive service that people want to use. We don't want to mandate. That's like the last resort type of approach.
Totally. All right. Is the framework used by developers part of the platform, or they can use any framework they like? Also, do you recommend creating Kubernetes operators to solve problems?
So framework is not part of the platform. That is and because we have multiple programming languages, so the approach is really containers. If you can package it in a container, then we are able to support you. We also support things outside of the container, but that is not part of the golden path. That is the 80% is really the containers of the problem solving, so to speak.
How often do you break the glass? And when that happens, is it mild? Do you try to bring them back in? Does that change your platform in any way and make it more flexible?
we have needed it once. And that's when we discovered that it happened to be an individual that happened to be the first one to set up the service, that whose personal email account was the one that we needed to restore everything. So we've stopped doing that, and we now have a generic email that we can actually then recover in case of this person not having access to his email, or yeah. So yeah, that's
Sounds more scalable.
Please learn from our mistake. Don't do that.
What size engineering organization are you servicing at this time? If you had to do your IDP over and could pick when to start, when would you have started? When would you start it as the company grew? Great question.
So the engineering organization as such is just under 200 engineers. And I would be hesitant to start too early because it doesn't provide good customers value. It is the promise of more efficient operations down the road. And in an early stage, say startup or just starting on your scaling journey, it's a significant investment. So I would be, so it really depends on the ambition. I mean, typically you want to evolve what you already have when you're hosting into a platform, because it's on PlatformCon, I heard the description that platform is what happens when DevOps engineers start talking to each other, which I think resonates quite nicely. So I think the best case is for this to evolve. I think our story is fueled by the business need. Then we're like, okay, we have to do this now, and we have to do it all the way, and then we can't really do it fast enough because it is really costly. And while building the platform, we didn't have just the 4 tech stacks. We got the 5th while building. And we don't really get the benefit before we can actually shut down some of the old ones, which takes time. And then you have to have an organization that is capable of dealing with that while doing it.
Yeah, I mean, what we have seen is, as a sort of like very rough rule of thumb, is over 50 engineers is when you probably want to start thinking about introducing a platform. Would you agree with that? Does that sound reasonable to you?
I think that sounds reasonable. I wouldn't do it before that, I think, because you can get very far on traditional hosting as well. So we were starting to see the cracks with the amount of teams, the amount of overhead trying to navigate and keep track of all the things that was going on in the organization. So we had to design for more autonomy, and that meant enabling empowerment for the teams.
Self-service, yeah. All right, I think we have one last question by Arthur. So how have you tackled on call, and is everyone from a particular product on call, or do you have platform level on call?
So right now we're a bit of a transition. So we have the traditional on-call where we have the one on-call team responsible for everything, but we are targeting more of a product-centric on-call, so that you have coverage of the individual products closer to than the ones that wrote it. So right now we do both, which is a bit cumbersome, but it's a journey. So, but the target is really to emphasize the subject matter experts on the products. They are the ones supporting the product, so that we will have on-call rotations dedicated towards that.
Makes sense. Jon, thank you so much. I think this is a really, really informative session. As I said, we'll follow up tomorrow with all the links and the slides. Also, if you guys have any other follow-up questions that you want to ask Jon, Jon is in the platform engineering Slack channel. And actually, I'll drop here the link so you have it. So you can also join us there. And if you have any follow-up, feel free to create a new thread. Jon, thank you so much. This was really, really interesting. Thank you, everybody, for sticking around the whole time, and see you at the next one.
Bye.
Thanks, Jon.